Hello, student of class 10. Today we are going to discuss uniform circular motion. Now first tell me, what is uniform circular motion? When a particle moves with a constant speed in a circular path, that motion is called uniform circular motion. But what about the velocity of that particle? Now observe in the picture. Here the velocity of a particle is always along the tangent of that point in that circle. Okay, so the velocity is continuously changing due to the direction of motion of the particle is continuously changes at each point of the circular path, because at point A the velocity is downward, at point B velocity is left to right, at point C velocity is upward, at point D velocity is right to left. So continuously the direction of the motion of that particle changes. So what happened? The velocity changes. So due to the continuous change of direction, the velocity changes, and thus the particle has an accelerated motion. When it moves along a circular path, that particle has an accelerated motion. Now let's go discuss what is the difference between uniform circular motion and uniform linear motion. In case of uniform linear motion, the speed is constant. Speed constant means the body covers same distance within same interval of time, and the velocity is also constant, because in case of linear motion there is no change of direction. So due to the constant of velocity, acceleration is also zero in case of uniform linear motion. But in case of uniform circular motion, we know speed is constant but velocity is not constant, so it is a accelerated motion. Now move to our next topic, centripetal force and centrifugal force. Now what is centripetal force? Before going to that topic, we all know that the velocity of that particle which moves in a circular path changes. So we know to change the velocity of a particle, it requires a force. Obviously it requires a force to change the direction of motion of a particle or change the velocity of a particle. So that force in case of circular motion is called centripetal force. Now the centripetal means center seeking. That means centripetal force is a force which acting on a body moving in a circular path in the direction towards the center of that circular path and helps that particle to change its direction and continuously rotates along the circular path. Okay, now this is the image of this centripetal force. The centripetal force, when the particle is at point here, the centripetal force acting towards our center, and when the particle is here, the centripetal force also acting towards center. So in all the points on the circular path, the centripetal force acting in the direction of center. Now let us see some example of centripetal force. Now electrons move around the nucleus. Now in case of electrons, the centripetal force is provided by the electrostatic force of attraction between negatively charged electron and positively charged nucleus. Now in the second example, planets moves around sun. We know in case of planets, the centripetal force is provided by the gravitational force in between planets and sun. And there may be another example, if a stone is tied at the end of a string and holding another end of the string in the hand, so and we are started rotate that string or that stone by that string, so where the stone executes a circular motion, uniform circular motion. In this case, the tension of the string is supplied the centripetal force which helps the stone to rotate. Now, centrifugal force. That centrifugal force, a force is assumed by the moving observer with the rotating body to be acting on the body in the direction of away from the center of the circle is called centripetal force. So this centripetal force is not a real force. It is a fictitious force or pseudo force which acts just opposite direction of the centripetal force, but the magnitude of the force of centrifugal force is just equal to the centripetal force, but the direction is just opposite, and that centrifugal force is only valid for an observer in the rotating frame. Okay, so the centripetal force is observable or valid for the observer which rotates with the rotating body. Okay, now finally we know that the magnitude of centripetal force and centrifugal force are equal and opposite in direction, but I clearly mentioned here that those centripetal and centrifugal force are not an action reaction pair force. Okay, why? Because they acting on the same particle or same body, but action reaction force does not act on the same body. Okay, now the magnitude of centripetal force is given by mv square by r. The proof of the formula is not in syllabus, but the formula is there. I am writing it, where v is the velocity of the particle, r is the radius of the circular path, and m is the mass of the particle.